everyone. In this video we're going to plot the spectrum of a WAV file. So I'm going to use three libraries. So we'll start with numpy. Import numpy as np. Next, of course, I'm going to use matplotlib. Import matplotlib as pyplot as plt. Then I'm going to import a scipy module. Import scipy .io.wav file, because we need to import our wav file first. So I'll call it wav. As you will see later on, it will look like the wav read, the old wav read matlab command. So first I'm going to import the signal. Suppose we have a file named chirp.wav, save in the same folder, because I named this tutorial.py. So it will be easier if it's saved in the same folder. So I'm going to import that file. So there are two output arguments. So that's fs, the sampling rate, and the data, the imported. So it's just wav.read the name of that was chirp.wav. Let me check if it's chirp.wav. Okay, that's chirp.wav. But this is a stereo file, so I only need one channel. So I'll call the new data signal, that is data. I'm going to slice through one column. So I'll take the only one channel for the first. I think this is the second channel. I think the first is index 0. So the next step will be to, I'll call this import WAV file into numpy array. The next step will be to apply FFT. We can actually use the RFFT. It's a one-dimensional FFT. There's no mirror, because the negative frequencies is just identical with the positive frequency. So I'll just call it say FFT, or just call it directly the magnitude equals np that absolute, because it's a complex number. So I'll now take np that fft that rfft, and then I will input here. The input arguments are the signal. So this mono file or mono array will now take its fast Fourier transform. This is the one-dimensional fast Fourier transform, but we'll take the absolute value, so we'll take the magnitude. Next is we can by the way, before that, we can actually verify if we have imported a file. We can say plot signal plt.show. Okay, that this is plt.plot. We'll verify first, so you can actually see that we have we're able to plot the signal. So now we're going to remove this, uncomment this. So we have now taken the magnitude. Next is we get the frequency values. So we have frec np.fft that the function name is rfft frec First, we're going to get the length of the signal. Next, we get 1 over the sampling rate. I'll call the sampling rate fs, so it's 1 over fs. Okay, so once you have these two values, we can already plot frequency versus magnitude. So you can have plt plot frec mag. We'll see plt that show. Okay, we'll see. So this is now the plot. Okay, let me check. Y is it's I think 1 over fs. Okay, it's supposed to be length of the signal and 1 over fs. Okay, but we can actually add all the other information, say, or the some labels. So we can have plt that x label frequency in hertz. You can have plt that y label. We shall calculate magnitude. We can add a title, plt that title, say spectrum, and I think that this should be all there is. Okay, so we can check. So we're now able to plot the spectrum. I can actually add a grid. So we have plt that grid. Okay, so we can now have your plotted spectrum of the bird chirp sound. Because you can see, I think the sampling, we can check the sampling rate. Fs is 44,100. So I'm going to run this again. So if it's 44,100, the maximum frequency is sampling rate divided by 2. So it should be around 44,100 divided by 2. This is the maximum value based on the Nyquist rate. And this is the frequencies from around 0 to somewhere around 7,000 kilohertz. So that's it. That's how to import a WAV file into a Python array and plot its spectrum.